This is going to be a quick video to help you with your homework that's associated with SLT 6, a quadratic and its inverse. It's going to focus on finding the inverse of a given function and the domain and range of both that function and its inverse, the restrictions we need to place on the original function. And just as a reminder, we're going to be doing all of this using our knowledge of functions and transformations. We are not going to be using a calculator. So let's just review the directions. A, state the domain and the range of f of x. B, what restrictions can be placed on f of x, I don't know what that does therefore, to ensure its inverse is also a function. State the inverse function, and then determine the domain and the range. So the first thing I'm going to do is I'm going to use my knowledge of functions and transformations to just think about the graph of number 1. I know it's a quadratic because there's a squared. I know that it moves right 3 and up 2. So I think in my head, okay, this graph is going to look 1, 2, 3, 1, 2. It's going to be a parabola. That's the shape of a quadratic. So now that helps me out because I know that the domain is all real numbers and the range is y is greater than or equal to 2. And of course there are other ways to write that, but that's how I'm going to write it. What restrictions can be placed on the function to ensure its inverse is also a function? So we need to remember that when, another color, when we sketch an inverse function, do it in orange, if I take this point 3, 2, then it becomes 2, 3, which is actually here also, and then I reflect, I would get this parabola, and this is kind of sideways, and this orange parabola, can you see it? Yeah. It's not a function. So the first thing I need to do is kind of say, all right, I'm only going to use half of the original. I'm going to color it in this turquoise color. And you can see if I were to reflect over the line y equals x, it would match up. I colored outside the line. It would match up with this part, which kind of looks like a square root function. We spent a lot of time graphing those today. So if I only use this half of the parabola, that means I want to restrict the domain to x is greater than or equal to 3. Now in theory you could also use x is less than or equal to 3, but like I'm a positive person and I want the positive numbers. Okay. C says state the inverse function. So if you need to, grab a piece of scratch paper and let's do a quick mapping of f of x. So to map out f of x, I'm going to subtract 3. Then I'm going to square it. Then I'm going to add 2. And that is the mapping of this function. To find the inverse, I'm going to do opposite steps backwards. So the first thing I'm going to do for the inverse is I'm going to subtract 2. So I'm going to start with x minus 2. Then I'm going to take the square root. Then I'm going to add 3. So here's my inverse function, the square root of x minus 2 plus 3. Oops. And it's kind of nice I already have that inverse, but if I didn't have this green inverse function to refer to for part D, I would know this is a square root function. It has moved right 2 and up 3. 1, 2, 1, 2, 3. It has a domain of x is greater than or equal to 2, and it has a range of y is greater than or equal to 3. So take a look at number 2 and think about the function type and its transformations and what the graph will look like. Hopefully you thought, okay, this graph moves left 7. I'm going to be kind of lazy about this. I'm just going to go like 7. And it moves down 6. Okay, I totally drew this badly because I have not left myself enough space. There we go. So now we've got negative 7, and let's say that this is like down 6. And here's the vertex, and it opens up because there's nothing going on out here. And that helps me see that the domain for number 2 is still all real numbers. but the range is going to be y is greater than or equal to -6. Okay. Now, the restrictions on the domain of this parabola, again, I only want this half. So I'm going to say that the restriction on the domain is going to be x is greater than or equal to -7. So again, I'm going to map out the inverse, map out the original function. This is the last time I'm going to do the long mapping. I'm going to subtract, I'm going to add 7, and then I would square, and then I would subtract 6. So opposite steps backwards. I'm too lazy to even write the whole function. It's going to be x plus 6. Then the opposite of square is to square root. Then the opposite of adding 7 is to subtract 7. So that gives me an inverse function of x plus 6 minus 7. Okay, here's my scratch paper. All right, so now I need the domain and range of this function. So again, I'm going to think about its transformations. It's the exact opposite of the transformations of the parabola. The parabola went left 7 and down 6. Here, it's going left 6 and down 7. So if I was left 6 and down 7, -6, -7, and I know it's a square root function, so it's going to look like this. The domain of the inverse is going to be x is greater than or equal to -6, and the range will be y is greater than or equal to -7. And I hope you noticed that we really did have a reflection here, because what used to be the range is now the domain. And what we restricted the domain to is now the range. It's kind of neat. Let's do one more together. Let's see if we can find a tricky looking one. I don't know which ones look super tricky. Maybe I'll do number 8. It's got a lot going on there. All right, so number 8, here it is. And number 8's got all kind of hot transformations. It's going to be a big old mess. It moves left 3, down 2, reflects over the x-axis, and has a dilation. The dilation is not going to affect the domain and range that much, so I'm not so worried about it. So I'm going to go left 3. And you notice that my graphs are just to help me, so they're pretty bad, and that's okay. I'm going to go down 2. There's my vertex. It's reflected over the x-axis, and it's skinny, so it doesn't really matter. So it still looks like that. Okay. The domain of this function will be all real numbers. The range will be y is not greater than. See, you get in the habit. I really have to think. This one is going down, so it's going to be less than or equal to -2. Just like before, I only want half of it. I just want this half. So the inverse will be a function. I'm only going to use x is greater than or equal to -3. Let me get my scratch paper. Let's map it out. So I'm just gonna list what happens here. I add 3, and then I square, and then times -5, and subtract 2. So that's how I would build this function. So I'm gonna do opposite steps backwards. So for the inverse, the first thing I'm gonna do is add 2. Then I'm gonna divide by -5. Then I'm going to take the square root, and then I'm going to subtract 3. All right. So as you're looking at this, I think some people are getting very nervous about the inverse function, and you really don't need to be, and here's why. So I'm just going to write that down. I know what the range and the domain of the original function were, so I can just switch them. And I know the domain of the inverse will be x is less than -2, and the range will be y is greater than or equal to -3. And again, because I'm switching these, the range becomes the domain, and the domain becomes the range. Hopefully you're able to complete the rest of them by yourself, and of course, as always, check on Google Drive.